and it's nice. So it's visual. It uses that skill from before, and as we move into this next unit, you have to be able to process that data too. Right now, you can think of that data as a list of numbers, a list of features, a list of any other kinds of things you want to measure or collect. And now, how do I put that all together? So one way is using the text function, which I'm hopefully you're going to be familiar with through this assignment. It's the processing text function. It works like a rectangle. One thing to point out as I was updating these assignments, this slide deck from Angie, not Angie, from Mr. Simon, I made some differences. So in Trinket, you have to use two arguments for like text align. There's a one argument version, and that doesn't seem to work. So that's one of the small nuances that occurred. In our simple example, you can click on this link where I have a little Trinket that has this code running and working, so you don't have to copy and paste anything. When we run this line of code, you'll see this kind of output. You'll see a bunch of bubbles, and my fake class has 46 students in it. Because only 8 of you have voted so far. 46 students are picking a random number from 1 through 10, and we kind of gave that list. Notice I put them into little bubbles. Also, I displayed it to the screen using that handy-dandy text function. Text size, text align, the gray text in the middle, and then the text for the numbers. And also to help me display that, there's the for loop down here, n, and then it runs through your list. So far, this is pretty familiar. Does it run? Yes? So from there, we build on that. Okay, so numbers, lists, and circles, we can do way better than that. So this next couple of slides walks you through those changes. Oops, this is like the wrong picture. So it was just supposed to be the gray numbers, no circles. Then we add circles, and suddenly we're being inspired by Hans Rosling, and we want to get that bubble idea. Why don't we try like tying then the frequency of the numbers to the size of the circle, so that let's say 11 was picked a lot, 7 was picked least, and then 5 was picked somewhere in between. So then you can tie that, and notice that it builds on that code that I've shared in the beginning, and I'm trying to highlight those minor differences that's occurring. Of course, we're using ellipses. That's what we're most used to. And then we layer on some more change. Why not then change opacity along with the color? Thinking about what other visuals suggest some kind of difference. Color, size, position maybe, to illustrate your point. So now we're tying that kind of frequency of the number that's occurring to the color of the shape. So now we have yellow being most prominent, and you'll fade into the background if you are less common. Another idea you can borrow for your assignment. And then, of course, we can't just use circles forever. Something more familiar to us probably in math classes or your stats class or science classes, bar graphs, very familiar across subjects. You can make your own version of those. In this case, the slide shows that we could make this bar graph going down, and frequency is represented by like the height of the bars. A quick reminder to the way that things are structured. Remember that the upper left-hand corner is the start of your rectangle, and it grows down your y-axis. So you have to kind of flip that logic to make them like grow up, and that's what this slide illustrates here. We shift the y-coordinate down a bit, and instead of adding, because y grows down, we subtract that distance. So now it looks more like this conventional bar graph. And again, we're still using that same set of numbers to help us visualize it. So this is where it gets interesting. Your data visualization assignment is pulling some data from a source. You can start with random numbers for now, and then I'll show you how do we pull some more interesting data from like a giant spreadsheet or a giant comma-separated file, a CSV file, so that you can represent, for example, cattle versus human population, or over time the amount of wolves in Yellowstone versus beavers or something. There's more interesting things you can do. But by all means, you can get started by building on this random list of numbers, even generating your own random number. Set of random numbers, do like 100 or so. And here's a change. You're welcome to work with a partner with this assignment. It's due let's say Friday, if you and your partner, you have the option of doing that, you're welcome to work alone in this, but two heads here, maybe you'll get a better visualization. And some more inspiration for you in the slide deck has a link to other common ways of visualize something. It's not just bar graphs and things. I have later examples in the slides where it goes over like circular arcs kinds of things. We have the bubble chart that is kind of illustrated in today's example. A bunch of neat things that you see in a lot of infographics, and you putting that visual prowess you have from coding up all these pictures and things together. There's some research articles on what kind of visualizations fits what kind of data, but here are just some more examples of that you're welcome to look through. A particularly interesting one, I'm on slide 21 out of the, on the slide decks, is the Chernoff face visualization. So this one, you kind of, the face changes according to some part of the data. So this is like a good example of that. So they have different names tied to their faces. A simple version of that is thinking about how happy a smiley face is, just thinking about the arc length of the smile. So eyes are symmetric. The smile is also symmetric in about how it does your arc. And then maybe increasing that difference, you get a bigger smile. That kind of change can be tied to like differences in data. And so if we were to visualize it, this one you'll have to type in yourself and modify it. But that same set of data, maybe since 11 occurs the most, this is the most smiley out of all of them. And it'll get more and more straight-faced as you are less frequent. You have your conventional pie charts, also using arc, but you're also like filling them in and thinking about the area. Side weight bars graph, you're welcome to make things like that and kind of tilt your axes. Radial bar charts, other things you're welcome to code up. And then I want to point out a couple things from your assignment prompt. So you've seen the student examples, hopefully from yesterday, browsing around, but also I want to point out these couple links. So I have on hand fuel efficiency data and Yellowstone National Park like population data. It also measures like the amount of like forest growth and foot cover. So this one has a bunch of different cars and a bunch of different data on it. So this is what I would call somewhat clean data. It's already been kind of processed, so you just take what you need, like copy and paste that, put it in a list into Python. This one too. Over time, it tries to measure like riparian browsing logs and riparian aspen log height. And then you have beaver colonies, bison population, grizzly bear. It has some temperature, precipitation numbers, and it's organized according to year and time. So maybe you can animate that. But notice that it's already organized in columns and things. So this is why you're going to fill out the Google form, so I can help you find already clean data. This little blog post. So like, let's say I want to get something on labor statistics, labor stats in the US. So maybe I find, like here, there's a lot of navigating you have to do, and then you have to clean it up in order to get the data you want. So maybe you want to figure out who is makes the most money currently based on the current population. So you click, they provide a graph, but then you got to look at all these things, and like maybe you'll click on this, and I want to find like this stuff. This is just for the year 2017, and they have this value measured in thousands of dollars for what kind of job? All employees nationwide. So this stuff maybe not as useful, but it's readily available, and I want to help you with like navigating and parsing through that. Notice this would involve a lot of copy and pasting. There are easier ways to help build that data set. So tell me what you're interested in. I hope this is a good amount to help at least get you started on your data visualization assignment. I wanted to point out these spreadsheets because it's a bit more interesting than random numbers. Questions, comments? Okay.